This video will explain each ocean floor feature and how it relates to plate tectonics. So I made a diorama and it is made of construction paper and some tape and a little imagination. So there are three regions of the ocean floor, which is the continental margins, ocean basin floor, and the mid-ocean ridges. So here's the diorama that I made. It's nothing fancy. We have the continental shelf, the continental slope, and it goes down to the opposite plane. We have the seamount, the volcanic island, mid-ocean ridge, trenches, the continental slope, and the continental shelf. We're going to talk a little bit more about the passive and active continental margin later on in this video. So here's a better depiction of the ocean floor. You can see on the left-hand side, we actually have the mid-ocean ridge, and then on the right-hand side, we have the trenches. And we'll talk a little bit later on why there's a difference on both sides. So this is an image of the seafloor topography. On your left-hand side, you can see the passive continental margin, and on your right-hand side is the active continental margin. So you can see that there's a slight difference between the two. On the passive continental margin, you have the continental rise, the abyssal plain, and also there's a mid-ocean ridge. Whereas on the active continental margin, we have the oceanic trench. This has to do with the plates. The layout of the ocean floor is heavily influenced by the moving tectonic plates, whether it's diverging or converging. Keep in mind, though, that they are always moving. A mid-ocean ridge or mid-oceanic ridge is an underwater mountain range formed by plate tectonics. This uplifting of the ocean floor occurs when convection currents rise in the mantle beneath the oceanic crust and create magma where two tectonic plates meet at a divergent boundary. Earthquakes occur along the faults, and volcanoes form where the magma reaches the surface. Convergent plate boundary is where two plates are moving towards each other. If the two plates are of equal density, they usually push up against each other, forming a mountain chain. If they are of unequal density, one plate usually sinks beneath the other in a subduction zone. The edge of the continental plate folded into a huge mountain range, while the edge of the oceanic plate has bent downward and dug deep to the earth, and a trench is formed.